Okay, welcome once again. I am Mwalimu Christopher Kalolo. Some of those who know me call Mwalimu Mwanakijiji, call me Mwalimu Mwanakijiji, but I am a data science instructor, software developer, but I also instruct students on software development, big data analytics, data engineering pipelines, machine learning, and also data analysis. As I say, today we are discussing Git Remotes. We have already done the foundational skills on Git, what is Git, and the foundational commands. And we also did Git branching. What is a branch? Types of branches. How can you navigate between branches, and et cetera, et cetera. And our third session was on Git merging, rebasing, and conflict resolution based on Git merge and Git rebase. And today's session is typically on Git remotes, and we start by understanding what is a remote and how can we explore different commands that works in this particular context of Git remotes. And when we talk about Git remotes specifically, we're talking about remote repos or remote repositories. Yeah, so let us start right away. Thank you for joining. I believe that this session will be very productive, and I believe that we all will be following this session not only by listening, but also you will be practicing the concept that we display on the screen. So I will be guiding you through the the concepts. I will be discussing you the theory behind the concepts, and also the commands that we will use to make the concepts the concepts come into reality, come into life. Yes. So this is our agenda today. We will discuss about remote repos and, of course, the real world scenarios. And of course, we will do how do we track remote branches? How do we initialize a local Git repo by using a Git Clone? We'll, in a nutshell, look on the special modes, shallow cloning, bare cloning, and mirror cloning, and the full life cycle of Git remotes. We'll find out the difference between Git fetch, Git pull, and Git pull rebase. And we will look closely on Git push, my Git push set upstream or the flag minus U force with the release or Git push force. How do we track branches in different cases? How do we inspect remote branches? How do we delete remote branches? And the hands-on at the end. So when we speak about Git remotes, most people will only think that Git remotes are repositories that resides on a particular platform such as GitHub or GitLab or Bitbucket. But that is not the real concept about the Git remote repo, because a remote repo is not a place. Specifically saying Git remote is a place is wrong, because it depends on the relationship between one repo and the other repo. So if one repo is tracking another repo, then that other repo becomes a remote repository, regardless of where it dwells. It might be dwelling on the same local computer, that is your computer. So one folder is a Git repo, another folder is a Git repo, and this particular folder is tracking another folder So we're saying the other folder is a remote repo in the same computer. See that? But you can find that two teammates or team members, they have Git repositories. So one member is having a Git repo in their computer and the other member as well. So in a setting where these computers are connected in a peer-to-peer network, for example, it might be a peer-to-peer network, or they are they are on the same local area network, or they are apart, but actually one member or one team member can reach the other member's laptop or computer or machine, we say. And if they can reach and they can track another member's repository, then another member's repository becomes a remote repository. See that? So that's how it works. But also we have the common scenario now where a remote repo sits on an online repository, sitting on online servers such as GitHub or GitLab or Bitbucket. And this is the most common one, which I think most of you guys who have interacted with Git repositories are used to. So actually, when we say a Git repository is a remote repository, we're not only talking about where it is sitting physically, but we're talking about the relationship between two repositories. So one acts as a local repository and the other one acts as a remote repository. Yes. So actually, when you are tracking remote branches, you will have your local branch and you will have a remote tracking branch. So for example, if your local branch is main, it will be tracking the remote branch called main, origin main. So we say the remote main is tracked by the local main branch, right? So when you git fetch, for example, the updates that are on the main branch and the remote branch, right, will come to your local repository, so your local main branch. But because you have just git fetch, they will not affect your working files. And what will happen is that you will need to merge your rebase in order for those commit history from the remote branch to come into your local branch. So this is how this interacts. You interact with the remote branch by, for example, if you want to take the history, the commit history from the remote branch to your local branch, you have to fetch them by using different commands such as git fetch and merge or git pull. But also you can send your local commit history to the remote branch by pushing them. So that is the mental model of how this works. Now we understand that from the beginning we showed you how you can initiate or how you can initialize a repository to become a Git repository. And we said you can make a local repository to become a Git repository by running a command git remote, git init. By running the command git init inside a repository, inside a folder, then you make that folder a Git repository. That's what we say from the very beginning. Now, there are other ways where you can initialize a local, a local project to be a Git repository. It is by cloning another project, which is a Git repository. So when you clone another project, we say you clone, you copy. So the command for that is Git Clone. You copy that particular project into your local environment or local setting. So when you clone it, what happens is that it will take all the working tree and of course the Git database into your local folder. And particularly if you do that, what happens is that your local folder automatically will be initialized to a Git repo. And not only that, it will be automatically tracking what? It will be tracking the remote repository that way. Now, before we go very far, let us actually do something that will show you what when we say this is a Git repository, tracking this Git repository. So this is a remote repo, and this is actually the local repository. What do we mean? We will start by creating a scenario. And this particular scenario will be both repositories are hosted on the same computer, the local computer. And then when you understand that model, then we will go to now working with, the repository that sits on GitHub. So we will basically use GitHub as our platform to practice everything that has to do with remote repositories. Now, before we proceed, I have a notification from our colleague here, Mr. Steven Macarius, who has a question. So please, Mr. Steven Macarius, you can proceed with your question. I am listening. Mr. Steven Macarius. Okay, you said just proceed. Thank you. Don't be afraid to ask questions. Questions are important because when you ask questions, it simply means to the facilitator that you are following closely. Because if you're not following closely, there is no way that you can ask a question. So thank you for that. I just encourage you that you ask questions. So let's go back to our computer. I want to now show you how we can actually make two repositories, one the remote repository and the other a local repository. So as I said, this is even possible for the same computer to have two different locations or two different folders. One acts as a remote repository and the other acts as what? As a local repository. So for example, we create a directory here. I think we are on the desktop. The print working directory. This is okay. CD okay, ls desktop is there. So let me move to desktop. CD desktop. So we are on the desktop. So I want to make a directory called local repo. Okay, let me create a directory called make directory called remote repo, right? And let's get into remote repo. So we are in the remote repo, so we can actually git init. Now, something which you also need to understand is that you can directly initialize and and you initialize, but at the same time you create the directory. So I could say git init and then write remote what? Remote repo. So it would go directly into, into it would create the remote repo directory and initialize at the same time. So you can do it in actually one command instead of creating a directory and then moving to that directory and then, initializing the repo. You could do it in one command, like that command. But because we already have, created the repo, I mean the directory, then we initialize it to become a Git repo. So if I say Git init, so our directory is now a Git repo. And if we list the contents, we will find out there is no content. But if we list the contents including the hidden one, so we will find out that we have the .git. This is our database. This is our repository. So the .git is the repository, which makes this particular directory, the remote repo, a repository. So here, the folder name is remote repo. We named it that way because we want it to mimic the repository, the remote repository behavior. So what do we do here? This is our remote repo. If we check, for example, git status, we found we are on branch master, no commits yet, but also yeah, nothing. Now let us get out of this of this project folder back to the desktop. So now we want to create another repository that comes from what? I mean, which is an exact copy of the remote repo. So what we do actually is to clone it. So we say git clone. So this is the command, git clone, and then we write the path to that particular what? To that particular directory. So usually when you're working on Windows, it's different when you're working on Unix. So Windows would require something like file and then // and then C slash, users slash admin. I'm writing my path actually. Admin one slash desktop slash remote repo. So now that's how I could do it. Now, because I am already on desktop, I don't need to write the full path that way. What you are supposed to do when you want to find the path to your repository, actually, you could go to the File Explorer, something like this. You go to your File Explorer, like this one here, go to your desktop, and then when you're on your desktop, go to that particular repo which you want to, this one here, which you want to clone, and then here at the top, I don't know if this is called, I mean, this is the path. You just click the path and then you can copy this path directly. Now, when you see this path, it says C, then users like this, C users. When you copy, come to to your to your terminal emulator, and then you will be required to paste. You'll be required to paste this way. But now, depending on how your Windows operating system handles, file paths, this might not work. So if we say, for example, git clone, this, it says cloning, you appear to have cloned an empty repository. So it has worked because I'm using git bash. I'm using git bash. But if I was using something different, for example, I'm using PowerShell. If I was using PowerShell, something like this, PowerShell, and do the same thing, Git clone, CD desktop, for example. No, CD. Okay, I'm here. If I say Git clone, and then put that path, and then give the name to the repo as local repo, what will happen? If I run this one here, it appears that cloning into local repo, warning you appear to have cloned an empty repository. Let us see if it has succeeded to do that. Local repo, okay, it has succeeded. But sometimes you might do the same thing and it won't work because of the way, Windows handles the way it handles the file paths. So if you have a problem with that, you can write a friendly command that looks like this one. So it will be something like, let me say, example repo. I will actually delete all these, and then instead of writing this way, if your Windows is unable to resolve the file path, then you could do something like this: file, and then 3 forward slashes, and then C, and then instead of backward slash, you could be using forward slash like this. You replace the backward slashes with forward slashes, like something like this: forward slash, then forward slash. So this also could work safely. See that? It has worked what? Safely. So if you have a situation where you need to resolve a file path and it is not working, the one which uses backslashes, then you could replace that by using this syntax here. Now, let me remove these repos which I just created, and then we do it afresh. Delete this one also. 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 Delete this. Delete this. Delete this. So we are going to start afresh. Now we have a remote repo as we started. If we cd, if we ls, list content, the remote repo is somewhere here. So our remote repo is there. Now we want to clone that, and we said because we are on desktop, what we need to do is just git clone and then the path to our remote repo, and the path is just remote repo, and this is because we are on the same root folder desktop, so we don't need to write the full absolute path that way. And here we name our folder will be called local repo, and if we click enter, now we have successful cloned what? A remote repo to a local repo. If we check our local repo, we are there and we can just see it. We don't have anything, but it is a repository. And in order for us to be sure it is a repository, we see that we are on master branch after just moving into the local repo directory. And if we want to be sure, we can just run git status. And as you can see, it gives us information that we are on branch master and blah, blah, blah. Now, if you want to know whether you are tracking a remote branch, because you want to know whether that particular remote repo is a remote branch, and in order for us to be sure of that, that means this local repo must be tracking that particular remote branch. And how do we do that? I mean, a remote repository. How do we do that? We say git remote minus v. Git remote minus v, it will show us the tracking repository or the repositories which are being tracked. As you can see, we are tracking this repository here called the remote repo. It's situated at the desktop. So it is origin, remote repo, origin, remote repo for both push and pull. So we are sure that we are tracking a remote what? A remote repository. So what is tracking the other here? Actually, local repo is tracking remote repo. And the way to see that is by just writing the command git remote repo, git remote minus v. So we are able to see this. This output tells us that, okay, this URL here, c/users admin desktop remote repo is our remote repository. So all the fetch commands will be done on that particular what? On that particular path. And instead of writing this whole path here, we don't write this whole path. Instead, we will be writing origin. At the same time, for push commands, we will also be required to only write origin instead of what? Of this whole thing here. So this proves that our local repo is tracking the remote repo. If we go the other way around, it will not work that way. So cd back and then say remote repo, we are inside there. If we say git remote minus v, it is not tracking any repository. That's why there is no output. So this, in that situation, the relationship between the local repo directory and the remote repo directory, or the local repo repository and the remote repo repository, is that the local repo repository is tracking the remote repo repository. So that is the basic skill or the basic knowledge of working with remote repository. Now, my plan is not to dwell here or to take time dealing with this kind of situation, because in the normal setting, when people are doing their code, we don't usually create two directories in the same computer so that another accesses remote repo and another accesses a local repository. But rather, we usually use online platforms such as GitHub, which is particularly a Git server, to handle issues of collaboration. And therefore, having said that, let us go back to our slides and look at a few concepts here. So we said Git Clone actually helps us to copy the remote repository into our local environment, and directly after we have cloned the remote repository, it will come into our local environment and create a folder which we will specify. Or if we don't specify the folder name, then it will create the folder name which resembles the name of the remote repository into our local environment. But also, automatically, the local repository will be tracking the remote repository. So you don't need to do any, any commands to make sure that the local repository is tracking the remote repository. But if you are the project lead, for example, and you are to create a structure, you are to create a project structure. For example, you are required to work on a particular project, say you want to develop a system that tracks urban, urban traffic flow, something like that, and you are a team lead on that project. You are the chief engineer. What will be required is to create a structure of your of that project, and the other team members will actually copy that particular project into their computers so that you can start collaborating. Usually, you will create a repository, for example, on an online platform such as GitHub, and then you will start working in your computer. So you have a project, you have started working with the files, you create that structure, and after that, you want to link this particular project with that particular Git repository on GitHub. So you will have a few commands that you will have to do in order for you to be able to track the remote branches, which we will discuss later. But now, before we proceed, these are the commands. So the commands you can use the HTTPS, or you can use secure shell to clone your repository, or you can use GitHub CLI. But usually, in this context, we might want to see in detail the HTTPS protocol, or if we can use the SSH protocol. By SSH means secure shell. So all these mechanisms are provided by GitHub. Yes. These special modes, we will not discuss them in detail, but let me actually explain what they mean, because I have a separate session which will be dealing with the different types of repositories. We have the standard repository, which will be dealing from today, but we have the bare repository. Of course, bare repositories are repositories which does not have a working tree. They don't have a working tree. And the use case is when you want to actually mimic a Git server. For example, you have a dedicated server at your work environment, maybe at your company, at your office, and maybe you don't want to use GitHub, but you want rather to use a particular computer at your workplace, which is a server, to act also as a Git server. So in that environment or in that setting, you'll want to use a bare repository. So we will talk much about bare repositories and mirror repositories, which is a special kind of a bare repository, in a separate session other than this one. But for you to be able to create or to clone a bare repository, you use Git Clone and then you add the flag bare. Or if you want to make a mirror repository, which is a special kind of a bare repository, you Git Clone and then you add a flag mirror. So it will create a repository from that particular repository, but this one now will be a bare repository or will be a mirror repository. We will discuss about these types or special types of repositories later, because I have a dedicated session for that. And we will see how we can initialize a repository as a bare repository or as a standard repository. Of course, whatever we did initializing repository by Git init, that was initializing a repository as a standard repository. So we have other commands that can be done in order for us to be able to initialize a repository as a bare repository or as a mirror repository. Yes. Now let us go to, before we proceed, let us explore a little bit GitHub. I don't know how many of you guys have GitHub accounts. I don't know how many of you guys have GitHub accounts, but if you don't have an account, actually what you'll be required to do is to write github.com on your browser. Let me sign out so that you are able to see how it looks like. So if we come to github.com, for example, something like this. Unfortunately, even when, okay, let me sign out first. Sorry, I didn't log out. So sign out. I'm signing out. So this is github.com. So if you are using GitHub, for example, you just write github.com. This is the landing page. So if you don't have an account, you'll be required to sign up. Unfortunately, if I sign up here, because I do have an account, it will just direct me to my GitHub account. But you will be required to sign up. If you already have an account, you will be required to sign in. So after you write github.com, just come here and say sign up. And then you will be required to sign up, for example, by using your Google account or Apple account. But if you want to sign up by using a different email, maybe you have a Yahoo email or a Microsoft email, whatever, any other email you can use. So you will come here and write your email and then write your password and suggest your username and blah, 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 your country or region. After you fill this form, then you will have successful sign up. But actually, I recommend that you use Google because it's very simple, it's very fast, is very clear. Just fast forward, use Google account, you'll have your account. After you have done that, then to sign in, you just sign in, and then you can say, okay, I just want to proceed with my Google account. And then you select your Google account. After selecting your Google account directory, you'll be taken to a GitHub account. But I also told you that not only GitHub, but also GitLab, for example. GitLab.com is another online Git platform which you can use because you can find another team using GitLab instead of GitLab. So you need at least to be aware of how it looks like. So this is a landing page. You see, when you write gitlab.com, you're taken here and you can just sign in or sign up. So I do also have an account here, but if you don't have an account, let me find out where you sign. Let me click sign in first. Maybe I'll find the sign up button. Uh, Sign in. Okay, so if you don't have an account, let me find out. Sorry. Unfortunately, I do have an account, so it's okay, okay. Okay. What if you write GitLab sign up? Something like this. GitLab sign up. Okay. So this is GitLab. So this is the sign up form for GitLab. Now, if you want to use your other email other than Google or GitHub itself or other, you can just fill all these information here. But if you want to use Google, you just click continue with Google. And since I said I do have an account, I don't need that. So I can just click sign in and then I sign in with Google. After signing in with Google, okay, I'm in. So this is my other account. This is GitLab account. Uh, As you can see, this is the interface and stuff and blah, blah. We're not doing GitLab today. I just wanted to show you if we are doing also something like Bitbucket, for example, Atlassian, bitbucket.com. I think bitbucket.com, yes. Unfortunately, it will take me directly into my account. So this is Bitbucket. Of course, this is my account also in Bitbucket. This is how it looks like. I used it more than 80 years ago, so I am not comfortable using it. So let us go back to our GitHub account. So this is your GitHub account. If you have successfully done that, you'll find out at the left there a sidebar which says top repositories, and you can click to create a new repository. You have a lot of, these. When you go here to, if you click dashboard, that is your home page. But we have other functionalities here. You have when you actually get into a particular repository, for example, you are invited to go to a particular repository, that particular repository will list all the working files, actually the working tree. You'll find which branch are you in. For example, here we are on the main branch, but we don't have any other branches. Or if you view all branches, okay. View all branches, we only have the main branch. See that? Yes. If you go to your repository, at the top you see these menu items called issues, pull requests, agents, actions, projects, etc. Some of these will have a special topic dealing with, for example, pull requests. What are pull requests? How do you do pull requests, etc., etc. So at the very first, if you find something like this, see that? If you find something like this, you have gone to a particular repository, for example, GitHub Actions, and you want this repository into your local repository. What do? You come to this button here, which is written code, and when you click the arrow, it will give you the three menu components: HTTPS, SSH, and GitHub CLI. As you remember, I said with these mechanisms provided for you to be able to clone a Git repository. So we will use the HTTPS. Actually, the SSH actually needs some configuration of the secure shell key and stuff and that. So we use directly the HTTPS. Now, this being selected, you can see others, the HTTPS of the SSH. This is the URL for SSH. If you want to do GitHub CLI, then this is the URL. But we are doing what? We are doing HTTPS. So this is our URL. So when you click at the end, this button here is for copying. So when you click this one here, you have copied it. Now our GitHub Actions repository has been copied. If we go to our desktop here, where we want to create a local repository from that remote repository GitHub Actions, what we do, we open our terminal. So I will open the GitHub terminal here, Git Bash. After opening Git Bash, I'm on desktop. So I'll just write Git Clone, and then I put that URL that I copied from the remote repository. So this is the remote repository, as you can see. And then I write my local repository directory name. So this is called GitHub Actions there. I just want to call Actions or CI Actions, something like this. Or let me call something more intuitive. Okay, Git, that is called GitHub Actions. Okay, let me call GitHub dash Actions. So click enter, it is cloning, then it is done. So you see, because GitHub Actions, that particular remote repository, if you examine it closely, you find it has all these files in the working tree, the SRC folder, tests folder, readme file, requirements.txt, GitHub/workflows. So this is our remote repository. Now, after cloning, let us get into that directory. It was called the GitHub Actions. Okay, we're in. So if we list all the content of that folder, we find this one here. So we have the repository, which is .git. We have the GitHub for CI actions. We have the README file. We have the SRC. We have the test. Everything that you were able to see there is now here. And if you want to be sure whether this is tracking that particular repository, you just write git, because you are inside now. Just write git, then remote, then say -v. If you do something like this, it shows you. So it shows you these two URLs for the fetch and for the push. So it says origin is a label for https:/github.com mwendisule/githubactions.git. So this is your repository. The github.git is your repository, your remote repository. It is both for the push and for the pull. Yes. So now it means you are tracking the remote repository. You are able to track the remote branches. Before we proceed now, let us see a few things. On that particular area. So after I've shown you how you can clone a remote repository into your local machine or your local environment, now let us see the life cycle of Git Remote. As I said previously, that you can have a local repository and a remote repository, but they are not able to see each other. Each of them is a repository, but you want to make sure that one points to the other. So these commands under create, all these helps you to link your local repository into a remote repository. Remember, what we did was linking a local repository to the remote repository automatically, because the Git clone automatically does that. When you clone a remote repository into your local environment, you actually have tracked it automatically. You don't need to do anything extra. But if you have two repositories, one is remote, the other is local, but they don't yet point to each other, you'll want to run this command. So the create command, for example, this under the create comment here, git remote add actually makes sure that your local repository is pointing to this remote repository. So if you have a remote repository called the repo, right? And you want your local repository to point to that particular remote repository, you use the command git remote add. Now, this word origin or this word staging, these two words, these are just labels. That in order for you to actually interact with the remote repository, every time you could be required to write this particular URL, the full URL, the full reference here. But that could be actually cumbersome. Actually, that could be tiresome, and writing this every time could be exhausting. So instead of doing that, if you have said git remote add, then origin, and then the URL, next time when you want to push to pull, you will just write origin instead of writing this whole stuff here. Or write staging instead of writing this whole stuff here. That is that is the reason or the rationale behind these two commands here. As I said, when you want to read the remote with their URLs, you just write git remote minus v. V is for variables. And if you want to, actually, for example, here we have origin and we have staging. So if your local repository is linked to more than one remote repository, if you write git remote minus v, then it will list all the remotes with the URL. So you could have, for example, if you write all these two commands under the same local repo, that means when you write git remote minus v, it will show all these. So it say git remote, it will write origin, and then this path for fetch, also for push, and it will also write staging for fetch and for pull. And if you have more and more and more repos linked to your local repo, they will be listed there. But if you want to actually be specific and you want to look into a specific repository, then you just say git remote show, and then that particular repository. For example, if you say origin, you mean this URL here. So it will show details about this particular URL and not otherwise. Right? If you want to know what I'm saying, let us do a practice a little more. What do we do? For example, we say we want to create a local repository. So let me open Git bash here. Let us create a local repository and initialize it directly. Call it, for example, demo. Let us call it demo. Git init demo. Enter. So we are successful initialize demo as a repository. If we get into this and you git status, you can see it's actually uh, a Git repository. Now, if we say git remote minus v, we don't see any output because right now it is not linked to any remote repo. But what if we want to link it? And now linking it with an existing repository, what we do is to go to that particular repository. For example, here now we come to our GitHub account, go to the repos. So for example, I have all these repos. I have a lot of repos actually here. All these are the repos. Now, what I want here, maybe I have the Rudovic and the Mathops. I want the Mathops to be linked to my local repo. So, or I can create a new repository as well. So I can come here and create a new repository. And that repository, let us give it a name. So create a new, so you can create a new repository, an empty one, and call it maybe Git demo. I call it Git demo. It says the name is available. Do you want to make it public or private? I want to make it maybe public so that any Git user can access it. But the private, you need to have some invitation to be able to see it, or some credentials to be able to access it. So let me leave it as what? As public. And what I do here, I also include the README file, and I create the repository. So the repository is created, is called actually Git demo. So I copy this so that I link, I want to link this one here with my local repository. Now remember, the local is already a repository. So what I will be required to do here is to come here. This is our local repository, Git demo. So remember when we said git remote minus v. Right now, it has no output because it's not linked to anything. So if you want to link it with that particular repository we created, we say git remote add, and then after git remote add, then you write a label. You write a label which is, for example, you want to call it origin. Origin, and then that origin is the label for this URL here. That origin is a label for that URL. So you click enter. Now, if we say git remote minus v, right now you are able to see the output because now our local repository demo is linked to our remote repository git demo. But as I said, you might have another repository which is only used for example, you want it for staging, and maybe what you'll do before you want to deploy it, maybe you want to, before you deploy it, you want to make sure that you have a staging repository. So you can come back here and create another repository. For example, I'm just calling it staging demo. Is a repository. So I'll say create repository because it's available. Boom. Now I can also want to make sure that this particular repository is also linked to that particular to that particular. So let me copy this URL here, and what I do now, I come back to my, I say git add, git remote add, then let us call this staging. Call this repository staging. So it must be .git. I will tell you what is the meaning of .git next time when we are dealing with the special types of Git repositories. So it's added. Now, if we say git remote minus v, watch what happens. So it lists everything. So the origin and the staging. Now, I said if we want to look into a specific repository, because Git remote v will list everything, all the repositories that are linked to our what? Are linked to our local repository. But if we want to look into a specific repository, then we say git remote show, and then, for example, we say show staging, something like this. See that? So it actually goes into that specific what? That specific URL, that specific repository. So our repository is staging demo. So it says our fetch URL is this one here, and our push URL is this one here. We can do the same by saying git remote, then show origin, for example. You see that? Now we are able to see this particular URL, I mean the repository, which is under the name origin. So that is the difference between git remote minus v. You are listing all the repository linked to your local repository. But if you say git remote show, then that specific repository, so it will show you that specific repository that way. I think I have a message from Mr. Steven Macarius, who is saying internet young and very sorry, Mr. Steven Macarius, but lucky enough that our session is being recorded. So even if you have missed some of the parts of whatever we are discussing here, I want to assure you that you will be able to find that what you have missed later, because this video will be available after this session, and I will make sure that today the link is added to our Google Drive so that you can be able to rewatch our session. Thank you very much, and very sorry, Mr. Stephen Makaris, for your encounters or your challenges that you are encountering right now. Now let us go back to our slides. As you can see, we managed to link the local with the remote. We managed to read the details. But now I want to show you how we can rename or how we can actually change the URL, because sometimes you might have pointed your local to a remote which is wrong. Or sometimes maybe the remote has been renamed, something like that, and you want to make sure that you're on track. So as you can see, this first command here, right, is for renaming the repo. Remember, we said we don't use full URLs. Instead, we use names. We use labels instead of those URLs to our repo so that it can be convenient. So you can rename it, but the second command is git remote set URL origin when you want to actually make some changes. Let us see it. Let us see it. Let us see it. Now come to our command line or our emulated terminal. So this is our emulator. For example, the second URL was called staging, right? And we don't want to call it staging. Maybe we want to call it upstream, right? The second URL is what? Is staging, this one here. And we don't want to use staging, instead we want to use a different what? A different name. So what do we do? What do we do is git remote rename, and then, so remember, every time we are doing this stuff, we must include the remote keyword. So from actual linking, or you want to read, or you want to update, you have to include the remote keyword like that. So if we come here to our command line or to our terminal emulator, for example, git remote -v, we do see we have origin and staging. And I want to change the staging into something else. For example, git remote, instead of staging, I want to call it upstream, for example. Now, if we git remote -v, you see now it's different. Let me clear my screen so it comes to the top. Git remote -v. As you can see now, we have origin and upstream, because upstream has been what? Has been renamed from, we previously we did have staging, and now it is called the upstream. So even now, if we can say git remote show, and then we say upstream, if we say now staging is no longer there, so we must get an error photo, as you can see, because we just renamed it. So now we could say git remote, then show, and then say upstream. If you say upstream, you're good to go. But also I said we can actually change the URL. Maybe we are pointing to the wrong what? To the wrong repository. But actually, what we wanted was to point not to staging demo. We wanted to point to, for example, git, and then remote. So how do we change? We say set URL. See that? Set URL. And then the upstream one was pointing to staging demo. But now we don't want that repository. What we want is HTTPS and then github.com/Mwendisule / now it's math. Is it MathOps or Joporo? I think I have a repository called joporo.git. So look, when we want to change, to update the repository URL, we use git remote set URL. When we want to link for the very first time, we use git remote add. Now here, the add is replaced by set URL. Then press enter. Now if we say git remote -v, you see it is pointing to Jopolo and not to what? To staging demo. That's the whole point. Thank you for that. Thank you for that. Let me pause for 1 minute. Not 1 minute, actually, 30 seconds. 1 minute, okay. 1 minute is okay. I'll be back after 1 minute. 1 minute. So as we said now, where were we? I think. Okay, so we have seen how we can link by using this command, git remote add, reading by git remote -v, git remote show origin if you want to go to a specific repo, how we can update the name of the repository. I mean, the label to the repository. If you say name, you can get confused. The label to the repository, how you can update the URL to the repository which we want to point. So I see, I think this is a message from somebody. Sir, may you please repeat the part of set URL? Okay, I will repeat. What we said is, you see now, if we come to let me minimize this one here, sorry. If we come to our original repository, let us come here to my terminal emulator here, git bash. You see now, we said git remote -v. So let me use PowerShell. I think there is a problem is the size of how much I can view. Let me use the same. I'll just do something like, okay, this will work. I will use the same git bash, but I won't make it full. I want to be able to see everything. Now the border hides some characters. Okay, for example, this one here, let us get out of this particular folder. We are on Git demo, I think. Git demo. Demo, yes. CD. Oh, I wrote Git demo instead of CD demo. Okay. Now we are on demo. Now, if we say Git remote -v, remember, you see you have two repositories. The first repository is Git demo, and the second repository is Joporo. What I just said is that first I showed you how you can link your local repository to a remote repository. And I said, doing that, what you need to do is just to copy your remote URL, for example. Let me copy another one, maybe Spark 2023 is a repository. And then I want to make sure that I link my local into this one here. So if I come here, I will say Git Remote Add. And then maybe I call it, okay, let me take another so that, let me use another one. And then I will come back to Spark. So let me say I want PySimilar, for example. But my idea is not PySimilar, actually. My idea is a very different repository. So here I will say add, for example, Spark. I want to point to the Spark repository. So I just want to call it Spark. And then, unfortunately here, the repository that I have just linked to is what? Is PySimilar. So if we say Git, then remote minus V, as you can see, we have origin, we have Git demo, we have PySimilar, and we have Geopolo. And then say, oh, no, that's not what we wanted. Actually, we wanted to the Spark to point to, this second repository to be Spark 2023. So this is a wrong repository, or the URL is wrong. We want to change that. How do we change that? We say git remote, then set URL, and then the same label, but a different repository. So our repository now is, our repository now is not PySimilar. Our repository is, our repository is Spark. I think it is Spark. Spark. Yes, this one here, Spark 2023. So I will copy the URL here. So what we are doing here is we are trying to update the URL to our repository. That's the whole point, right? What we are doing here is to just update the URL. So in order to update the URL, you don't say git remote add, but rather you say git remote set URL. And then the label is the same, but what we are changing here is what? We are changing the URL. So I didn't copy. We are changing the URL. So our URL is this one here. So let's go back. So here, paste. So you see now, the previous one was PySimilar.git, but I want to change the repository to Spark2023.git. So if I click enter here, you see, if I git remote minus V again, what is seen here now, the Spark label is tied to Spark 2023 and not PySimilar. I think you have understood, my brother Zoom user. Who is Zoom user anyway? So thank you very much. I think you have got what is the point I'm trying to make. Now, let us go back to our presentation. As you can see here, you have the last one is the remote set URL, git remote set URL. But for example, here, what you are doing is the same thing as you are doing here. Actually, this command with the flag minus push, what it does is saying, please, under the label origin, if you are pushing code, push to this particular repository. So, which means you can have you can have your repository linked to two different repos under the same under the same label. For example, origin, when you pull, you are pulling from a different URL, and when you push, you're pushing to a different URL. For example, if we say, if we say something like, now I want to make sure that set URL Spark. I want now, when I push, I want it to go to PySimilar. PySimilar.git. So here, I must add a flag minus push, something like this. So if I get enter, then let us git remote minus v. Now look here. If you say, when you push for this Spark label here, if you want to fetch the remote commits, you will use this particular URL. Actually, it will be taken from Spark 2023. But when you push your commits, they won't go to Spark 2023, but rather they will be going to PySimilar repository. So maybe you want to make sure that you'll be taking commits from your fellow team members, feature into your project, and then when you push, you want to push to a different repository. Maybe you want to deploy that particular repository, although that is not necessary, but this is how it works. So when you say git remote set URL and then you put this flag minus push, and then you put this particular URL here, it means whenever I want to push, then the push will go to this URL instead of Spark 2023 at the many. And then another thing is when you want to delete, the linkage. For example, we have staging or we have anything. If we say git remote delete, I think it's git remote delete, if I'm not mistaken. Remove, so not delete. Git remote remove. What it does, git remote remove, sorry. It removes the link between these two repositories. For example, if we say remove, we have origin. Now if we say git remote minus v, we only have two, Spark and Upstream. If we say git remote remove, for example, Spark, if we say git remote minus v, we only have now a single repository. If we say git remote, then remove what? Remove upstream. Then, so git remote remove, this is upstream. Okay. Now if we say git remote minus v, as you can see, nothing is happening, no output, because now our local repository is not linked to any of the remote repositories. Yeah, so that is it. These other two commands, the git fetch prune, okay, now I won't speak about them too much because we must first discuss git fetch pull, git push and stuff. So let us discuss in a nutshell these these three commands. Now, as you know, Git remote aids collaboration between team participants or team members. What does it mean? It means we will be 4, 5, 6 people working in the same project. So every person is working on their module. For example, developing a student information system. Maybe Mwalimu Kalolo is mandated to develop the lecture module. Then another person is mandated to develop a student module, and the other one is to actually write the module by mean those modules which students learn. Now that particular module, and another one is the graduation module, and another one is the results module. You know, but it's the same project. In the end, when we deploy that project, it will be a comprehensive, complete, whole project. Now, in order for us to be able to collaborate, that means every time when we are working this particular project, it means every time, every single time, I must make sure that I am updated. My local repository contains the full copy of the remote repository, which means the work of other colleagues will always be available also in my local repository. So we have a remote shared repository, and I have a local repository. So if I have my modifications, I write files, new files, I delete files, I modify files, and then these changes will be staged and committed so that we can push them. We can share them with my other colleagues by making sure that I send these commits into the remote repository. So another person in their local computer working on the same project, what they will do in order to make sure that they have the commit history from my side, they will need to pull those commit history. So those changes will be pulled into their side so that they can have the same exact copy as mine. So in that particular setting where collaboration is needed to that extent, then you must understand the concept of git fetch, git pull, and git pull rebase. So what does git pull do? Git pull actually, git fetch first, git fetch. So if say git fetch origin main, that means you are fetching those changes, the commit history from the remote repository into your local machine. But when you git fetch, what happens is that your current working tree will not be touched or affected because those commits will come into your local environment, but will be allowed into your working tree. After that, you merge those commits. So you must say git merge. So you git fetch first, and then you git merge so that you can incorporate those changes into your local working tree. But when you say git pull origin main, you are doing two commands in a single line. You are saying git fetch and then git merge. So git fetch actually is great if you want to explore the changes before you merge them into your local environment. But if you don't want that, you can just say git pull. When you say git pull origin main, you're pulling from origin to your local main branch. You're pulling directly to your local main branch. So in that command, what it does is actually it fetches and merging at the same time. When you say git pull and then you add the rebase flag, what it does is actually performs rebase instead of merge. Remember, we say git fetch must be added by or must be followed by git merge. But git pull actually does two, fetches and merges at the same time. Now, when you git pull rebase, you remember we discussed about the difference between merge and rebase. If you don't know this or you didn't see uh, this particular video, we advise that you go back to that particular video on Git merging, rebasing, and solving merge conflicts. So please, merge conflicts, rebase, and merge are discussed from our previous session, and the video is on our Google Drive. You can just go there, download that video, and please watch it to understand these concepts. Now, if you want to merge, you just say git pull. If you want to rebase instead of merge, you want to clean a history into a local repository, then you say git pull rebase and then origin main. It will do the same thing as git merge, git pull, but with rebase instead of merge. I will show you in a minute. When we come to git push actually, when you want to share your local commits into the remote repository, you use git push. So you must say git push, then you git push origin main. Actually, you upload your local commits to main on the remote branch. But if you say git push and then set upstream origin and then feature, you push a new branch. This is specifically for new branches. You push a new branch and set up tracking in one step. So you remember, if you have a new branch, actually you would want to make sure that that branch is tracking a remote branch. Now, instead of setting the tracking first, and after setting the tracking, then you come to what? To push to that particular branch. What you do, you can do it in one command. Git push -u is a shorthand for set upstream. So minus set upstream stands for, is represented by -u. This is a shorthand for set upstream. So you may want to use the full flag set upstream, or if you use -u, is just an alias for set upstream. So the same thing. So when you say git push -u origin feature, you have set the tracking branch, and therefore next time when you want to push under that particular branch, you don't need to write this command here, git push origin main. What you just want to do is just git push. It understands that origin is linked to that tracking branch is linked to feature. Now there are situations where when you are collaborating, for example, in the same repository, especially when you want to push to a particular branch. But now, if everybody is pushing to that same branch, git push would be rejected because you are required first to do what? To pull the commit into your local environment so that you don't destroy another team member's work. So when you say git push force with Liz, it says force push only if nobody else has pushed to that branch since you last fetched it. So for example, you git pull origin main, right? And then you work into your local environment, and then you modify some files, and then maybe before you push, there is no other person who has pushed it. That means you can just git push if you are pushing to a shared branch. So you can git push force with Liz, which means it will only push if there is no other commit from your fellow colleague. But you may say, anyway, I am the master here. I can overwrite any other's commits. You can just say git push and then force. Then when you apply this flag force, it means you overwrite the remote branch despite the fact that others might have committed to the same branch. This is not safe, actually. This is not safe. We will see in a moment. Now, the last thing today is tracking branches. Tracking branches. We have three cases. For example, you have a remote branch and you want the local copy of that that tracks that particular branch. So you have this command which says git switch -c and then feature, your branch here, and the tracking branch, the branch that is on the remote branch. If you do this, that means this particular branch that you are creating will be tracking that particular branch on what? On the remote. I am afraid that our time might be consumed and we're not done with the practical part of these scenarios. So let me see here.
Sorry, sir, I have a question.
Okay.
Kuna kitu hapo nimeona hapo umeandika, kuna link hapo ya account ambayo unaandika kama say hapo, mimi nilijaribu kufanya na unaweka kama na credential fulani hivi ambazo unatakiwa uziweke ili ikakupa authentication na kuingia kwenye GitHub yako kupitia kwenye CMD.
Link
Ili
account.
ukiwa yani kuna namna mimi nilivyofanya hivyo nilivyotufundisha. Sasa kuna sehemu nilikwama ikanidai niweke credential, yani kama mfano kuna token token yani unaicreate kwenye ili upush kitu, kuna token ambayo unaiweka kwenye SMD pale, unaitoa kwenye GitHub, ambayo ukiweka hiyo linki inakudai kama upate authentication fulani ambayo itakuruhusu wewe uweze kuingia kwenye hiyo account yako wewe ambayo unataka kupush, ili ukipush vitu vile vinaenda.
Now, because
Sasa
I haven't come to that juncture, I haven't pushed any code yet. Maybe if I could have come to that extent, then it would be now a relevant question to me, because I know that those jargons can happen. And now when we come to that particular moment when I am pushing, I will have the same challenge that you are having. Okay?
Kuna bado swali sijalimalizia vizuri.
Okay.
Sasa tukija kwa ule ambao umetufundisha hapa, itakuwaje sasa mtu mwingine akipata nani yako akipata
you are lost, please. Can you come back? Hello, Mr. Steven Macarius.
Kwa kupitia Git kuna security yote ambayo inaweza kaallow kama authentication
sorry, please. I think you are lost. Can you repeat your question?
Okay, my question is nimeona unaingia kwa link kuna link ya kupush kwa GitHub, lazima uweke link ya GitHub kabisa na ya account yako, au nimeona vibaya?
I haven't pushed yet, so I don't understand what you are saying.
Yaani ulikuwa ndo unatufundisha zile link za kufanya hivi za kudelete
No, now I think you are getting it wrong. Let me repeat, because it is just right here. Let me go back to where I think you are getting confused. This particular command here.
Okay.
Are you referring to this particular command?
Yes.
Git remote set URL and then push origin. I was not pushing here. I was not pushing here. What I was doing here was to link my local repository to a particular push URL. Because what I said here that always when you actually link your remote repo to your local repo, you will have the same label. I mean the same repository for fetch URL and push URL. But I said sometimes if you think that you have special requirements where you need to push to a different repo, pull from a different repo and push to a different repo, then you have to add this particular flag here. Now, what you're asking, I don't know whether, because you said maybe you said you pushed or you just ran this command. I don't know whether if you ran this command, if it required you to put any credentials. But if that is so, then we will see, because I will come to that juncture where I explain now how to push and how to pull, and of course, how to generate those personal tokens, personal access tokens from GitHub, which will help you actually access your private repo that way. Especially when our repository is private, you must access that repository by using the personal access token. Now I will show you in a minute. Okay, thank you for your concern. I said we have three cases when we will need to track uh, remote branches. For example, you have a remote repository and there is a branch that exists on your remote repo, but it doesn't exist on your local repository. So the command to make sure that you link that local branch to your remote branch is this git switch minus c feature. You remember this command actually creates a branch called feature. And when you add the remote branch here, what you're telling Git that please create this branch and link this branch to that remote branch. So from now, henceforth, this branch will be tracking this branch. When you push, when you pull, actually, when you are here and you write push commands or pull commands, they will be directly going to this particular branch. Then the second case is you have a local branch and you don't have a remote branch. This case, you just publish it. And publishing it just git push minus u origin and then feature. So when you write feature, this your feature here will be created. This branch feature will be created to your remote branch. And of course, the last scenario is when your local branch is pushed, but tracking was never set. You have to retrofit it by using this command git branch. Then this is set upstream too. Now you can get confused with this set upstream here. This is set upstream, and actually is set upstream, and then you write the remote repo and the what and the branch that you're pushing. But here, when you say set upstream, is set upstream too, and then you write that particular remote branch. So those three scenarios can happen in your code cases. So we will see all of them. We will see all of them. Now let me do something to favor Mr. Steve. I think that guy is called Steven Macarius Abraham. The voice is Mr. Steven Abalambo, I think, something like that. I don't know. Okay, let us come here. Let us see now a lead project. For example, let me make sure that I go to a particular repository that do have a working tree with a lot of files. For example, the math ops, for example, math ops, math operations. Sorry, are you able to see my screen?
Yes, we see your screen, which is says that Python math project.
You are able to see my screen, right?
Yeah.
Okay, okay. So this is our remote repo, which we want to clone into our local repository. So let us clone it. I want to make sure that Mr. Steve understands that particular concept. Let me find out whether this is private or public. I'm not sure. This repository. Okay. Let us. It is public. I want to. Can I make it private? Settings. Let me go to settings. Let me try to. Methods. Methods. Okay. Method. I think I have forgotten. Okay, here. Change visibility. Change to private. I want to make this repository private. Okay. Okay.
We don't hatutaka kuhaki picha, tuone tu.
Pardon? Please, can you repeat?
Nasema tuonyeshe tu screen, hatutafanya chochote.
That is not the purpose. When I'm saying private, it doesn't mean. Are you not able to see? Hello, Mr. Steve. Is my screen not seen?
Inaonekana.
Hey, making it private doesn't mean that you cannot see it here. It means that you cannot access this repository if you don't have the credential. That is the meaning. So if
Okay.
if I give you, you must be invited in order for you to be able to clone this. So, for example, if I want to clone this, I want to clone it to our desktop. We have this one here. So, okay, now we are creating a brand new repository. So let us say this is Git Clone, and then let us put this. And then what is the name of our project? What do we name our local repository? What do we name it? What name do we give to our local repo? Okay, math. Let me call the same name, math ops. So if it's the same name, then I don't need to specify it. I just enter.
Okay.
Because if the same name, there is no point of writing a name because the same name. Okay. So CD. Okay. Now let us use Visual Studio Code or something like a PyCharm. Let us open Visual Studio Code or PyCharm. Okay, this is PyCharm. They are Python codes, so I'm using PyCharm because they are Python codes. So what do we want to see? I want to see how we can push, we can pull, we can do this, we can do that, etc., etc. Now remember, we are already having this particular methods as a local repository. A local repository. Okay. So this is our PyCharm IDE. I want to open this particular project. It is on desktop. I think, yes, this is admin one. This is desktop. And we have math ops. So this is our project. This is our project. Trust this project, yes. So what we want to see here, we want to see whether we can push and pull. Now, let us see something here. Okay, if we say git status, for example, it says untracked file is git add ID. So this is an IDE. Let us go add a file called git ignore, because you don't want to push that file to. It's just a file called it .git ignore. Okay. Now that is idea is actually is a folder. So ID git ignore itself should not be pushed. Okay, after that now, if we come back here to our terminal emulator and say okay, git status, modified git ignore, modified git ignore, git add git commit, my git commit, add git ignore. Right? Now, the first challenge that you are going to have, you will not be able to commit if you haven't configured your identity, right? This is why I was not able to commit here, because you see, Git doesn't understand who is committing. So the first thing before you commit, you must set your identity. So Git config. You remember our very first day, we had this. Now, I want to make sure that this is just for this project. So I'll say local, and then user.name mwanakijiji, and then git config local user.email. Then my email is this one here. Git config. Okay, I misspelled this one here, sorry. This should be local. Okay, we're good to go now. Now, if I commit now, I will not have that particular error. See that? We're good to go. So, for example, if we, for example, in our requirements.txt, we have this particular, you can see this particular what? This particular libraries which are the requirements for anybody who is running this project. What if we want to add PySimilar? For example, we have a library called PySimilar. We have a library called, okay, PySimilar, something like this. And then we save. If we save this, if we git status, we find something like this one here. But remember, Git remote here is able to tell us where are we actually linked to. So git, let me clear first. So git status says we're on a branch master, and our branch is ahead of origin master by one commit. So you see, in our origin master, in our remote branch, we are ahead by one commit. We modified these requirements here. If we go to that particular branch, if you open read.txt here, you see we don't have the PySimilar. We don't have the pi similar. So what do we do? And our branch is what? Our branch is master, I think. If we come here, we see our main branch here is called the master. Yeah, so what we'll be required to do is to make sure that if we want to see those changes at our remote branch, we say git push. Then if you say -u, it means you are setting this branch to be tracking that branch, because you could say just git push and then origin master, because we are pushing these commits here to our branch origin master. We can't just say git push, something like this, git push. It will work if it is already tracking that particular branch, which in this case, it seems it is already tracking that particular branch. In order for us to be sure, we come to this particular branch here. If we refresh, if we refresh, we will see that particular commit. And that commit says add git ignore file, right? Add git ignore file. So we are good to go. Now, for example, what I just said is we just git push. But for example, if we list the branches here, git branch, we only have master. If we say git branch -a, you see we have master, but also in the remote, we only have master. Now we can say, okay, let us do something. We just want to create another branch called dev, right? And what we said is that if we want to track this branch directory, our 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 code should be something like this one here. The remote branch exists. You want to have a local copy of it. Now we don't have the remote branch, but the local branch exists and there is no remote counterpart like this one here. What you need to do is to run this command. You publish that branch. So for example, if you say git checkout dev, we are on branch dev. You say git push -u. This is the same as set upstream, like something like this one here. Set upstream, and then origin what? You origin dev. This means this branch will be published to what? To our remote repository. So when you go to our remote repository here, right away, if we now examine the branch that we have here, we have two branches, as you can see. Another branch is called the dev branch. See that? Now, if it happens that, for example, we delete the local branch, git branch -d dev cannot delete branch used by the working tree. So we must get out of this. So git switch master. So we're out. Then we say git branch -d, then dev, then the branch is deleted. So if we say git branch here, we don't have any other branch other than a master. So we go to the second scenario. The second scenario says remote branch exists. You want to a local copy that tracks it. So in order for you to be able to create a local copy that tracks an existing branch, you run this command here. So in this situation, if you come here, although I have deleted the local branch, you still have two branches here, and these two branches are master and dev, right? Yes. So what you're required to do here is to write this command if you want actually that branch to be tracking this branch. If we say git branch, sorry, git remote, is it git remote branch or git what? Okay, I will find out in a minute. But here now, if we say git switch, for example, git switch, then -c, and then I write development, and then origin/dev. It means I'm creating this branch called development, and immediately after creating this branch, I want it to track this remote branch. Yes. So you see development setup to track origin dev. You see this one here? Branch development is set up to track origin dev. Switch it to a new branch development. Now that is the second scenario. But the third scenario is when, for example, delete this one here. Git branch delete development. I must get out here git switch main. Sorry, git switch master. Then git branch delete development. See that? We have deleted. Now, the third scenario is when you have a local branch and the remote branch. So if you say git, for example, switch -cdev, we've created a local branch, but this local branch is not tracking any remote branch, right? So in order for us now, we say the third scenario, tracking branches, the third case is a local branch pushed, but tracking was never set, retrofitted. So if you say git branch set upstream to origin feature, now it means we actually want to link our local branch which is existing to a remote branch which is existing. These three scenarios, the first one is the remote branch is existing, but we don't have the local branch. So we create a local branch and track the remote branch at a single command. In the second scenario, we have the local branch, but we don't have the remote branch. So we just publish it as you saw it. The third scenario, we both have local and remote, but these are not linked to. As you can see here, if we say, sorry, let me show you. If we say git branch minus, sorry, let me clear first. What is happening here? So, okay. So git branch minus v, minus v variables. This is called variables. You see, we have dev, dev add git ignore file, master origin master. So you see, the master is tracking the origin master. The dev is not yet tracking anything. So if you say git branch set upstream, branch, then set upstream to, then you say is equal to origin slash what? Slash dev. Now, branch dev is set up to track origin dev. Now, if you say git branch minus VV, if you see now, dev is also tracking what? Origin dev. So I wanted to show you these three scenarios. These three scenarios, how you can set tracking branches from scenario A to scenario C. Now, as you saw now, Mr. Steve was asking a very important question that he wanted to push, but when he wanted to push, something happened. He was required to actually, he was required to set a personal access token. Now, in order for you to be able to set a personal access token, is by doing something like this. When you come to your Git repository, like this one here, always you will be required to supply credentials when you want to access a particular repository. In order for you to do that, then you come to your profile here at the very right icon here. When you click it, you will find menu components here, but one of them is settings. If you click settings here, now you can see that mine is just working because I already made this configuration. But if you just if you just do something like that, when you come to settings, just scroll down. You will find somewhere a link called the developer settings, so a menu component called developer settings. Click that. When you click that, it will take you to the three options here: GitHub apps, Git Auth apps, and personal access tokens. Now, in the personal access tokens, just click tokens class, and you will be required to set your access. Now I have an access token. That's why everything is working. If I delete this, for example, let me delete this. After deleting this, let me try something so that we can understand what it means. So after I have deleted my personal access token, I just want to go back to main. So git switch master. So it's master. Git switch master. So I want to create another file called git. Sorry, not the git. This is called just touch. Oh, okay, touch. It's an empty file. Touch. Call it check ops.py. Okay, let me just write something in it. Print. Hello, PyCharm. I'm writing to a file called greetings.py. Then if we git status here, you see we have something modified. So we say git add the file git commit -m, then say something like add greetings.py file. This is how we write commit messages. You don't say added, you say add greetings.py file. It's very descriptive. Then if we say git push, let us see what happens. Okay, it has gone. Git, let me check that particular file again. I just want to mimic to create a scenario where I will be required to actually. Okay, git push. Actually, be demanded to put a personal access token. I'll find out. Maybe next time we'll be able to do that. Okay, now, but what you are required to do here is to, when you come to this particular juncture, you just say generate new token. So generate new token, generate new token. I prefer, this is fine-grained repo scoped, but I want it for general use. Oh, let me do for repo scope for this repository. And then I will have to give a token name. So my repo, I want to call it PAT, sorry, PAT, then mid-July. I just want mid-July. I call it that way, mid-July. I can put it a description, blah, blah, blah. This is repository access, public repositories, read-only access to public repository. Oh, let me do something else. Let me do not fine-grained. Let me do for the whole stuff here, generate new token. I want for general use. Okay, PAT mid-July. I want it for 30 days. I want it for 7 days from today. This will be for repo, for workflows, and blah, blah. Okay, generate token. So you come here at the end, it says generate token, and then this is your token now. You can see this is your token. This one here. Make sure you copy it, because after you exit this page, you will not be able to see it again. So you might want to copy it somewhere. For example, you want to put it on sticky notes, something like sticky notes, and make sure that you put it somewhere. For example, let me put it there. I will come and find it there. Now, if you exit this page, for example, you exit this page and you come later again, you will be able actually to know that you have this access token, but you won't be able to see it unless you want to regenerate, but you won't be able to see it anywhere. See that? Now, when you are required to put an access token, like Mr. Steve asked, that place where you have to put a password, you have to paste that access token. You just paste it and you are done. Okay, now we have seen scenarios where we can push and pull. We can push, we can pull. We can push, we can pull. I want to show you a scenario where you have to set a tracking branch. For example, I said, if you just say git push and it works, is because the branch is already tracking. Because if you say git branch and say minus VV, you're able to see that every branch here is tracking a particular branch. So what do we do here? Let me git delete git branch and then delete dev. Now I want to create it again, git switch minus C dev. So if I say git branch minus VV, I see that dev is not pointing anywhere. So if I say something like my file now is greeting.py, this one here, no Python interpreter, blah, blah, just leave it alone. If I say print, I am here, right? Print hello, PyCharm, and then print I'm here, and then save. I'm on dev. Right now I'm dev. If we say git status, I am on a branch dev. So I might want to make sure that I want to push those changes. So git add greetings.py, then git commit minus m, and then update greetings.py file by adding the line print by adding the second line. Something like this one. One file change. So usually you could say git push. Now git push, it says Fato, the current branch dev has no upstream branch. You see what I was saying now? So let me clear it here so that you can see it well. Clear. So git push will throw an error. And you see this error, it says Fato, the current branch dev has no upstream branch. To push the current branch and set the remote as upstream, use git push, then set upstream. So this command which you see it here is the same command which we show you here. So if you come here, you will see that I showed you a command. That particular command is, you see, git push -u origin dev. Push a new branch and set up tracking in one step. Now, remember we have a branch dev there, which we could just do something like, you know, we add these commands here. We have the branch. So if we retrofit here by using this command, the third command here, then git push could work. Now, because we haven't set the tracking branch, what we are required to do is to run that command. And running that command is saying something like this. So if you say, okay, git push set upstream origin dev, now it has worked. Next time, if we, now this set upstream origin dev, the set upstream is the same as -u, as I said. So you could have just written this command here. Instead of set upstream like this, you could just have written u. It works the same way. Now, after you are done with setting the tracking branch in the same command, that means you could have used the git branch, then set upstream to, and then origin /dev. And then after this command, then you come to run another command, which just says git push. But this command here does these two in one command. So this command here does two commands in a go. Next time when you just change something here, for example, you say print, I'm here, print goodbye, everybody, and then you save. When you get status here, you see that you have made so you use the add that particular file and then git. Let me clear first so that you can see. So git commit -m. So add update or add the third line to greetings.py. See that? Here now I can just say git push. It must work. It must work because we have already set the tracking branch. So it knows where to send those commits. It knows these commits must go to where? They must go to, they must go to the dev branch in the remote. So when you come to the remote here, if you come to the remote here, go to home page, check that particular, I think it's MathOps. Okay, MathOps, then select the branch. The branch is dev. Now in branch dev, you see all these. You see all these. So add the greetings.py file, add the headline to blah, 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 add cost not for publishing. All these are not listened. So, okay. Add the greetings.py, add the headline to greetings.py. So if you open this one here, you will be able to see greetings.py file. So let me go back and open greetings.py, this file here. We are able to see these 3 lines. However, if you change the branch from dev to master and open again greetings.py, you don't see those 3 lines. You have to create a pull request so that you can merge into the main branch. What I want to show you again is actually making a change from from this side. For example, we say publish branches with caution, and then we want to edit this particular file, want to add another line. And the line will be the 7th line, which says, goodbye for today, right? And then we commit the changes. And the changes, Copilot has helped me to create a message. And when we come, so this is the master branch. So when we come back here, when we come back to our code here, what we can do, we can just git, okay, now git switch master, sorry. So if you say git pull origin, you don't say just git pull like this one. You specify actually. Is important to specify, but because it is tracking the remote branch, git pull just worked and that it performed a fast forward merge. And the reason of performing the fast forward merge is because we haven't made any commits to our local master branch. So this git pull will have helped us if we go to actually look on the README file. We'll see that the 7th line has been added. Goodbye for today. So that's how you actually work with remote repos. Another thing which I should actually explain, because I just told you that you can git fetch and git merge in 2 steps. So here, if I say goodbye for today, and then I say see you next time, and then commit, and then commit the changes. So this is the last point. So if we come to our local repository, if we say git fetch, this is the origin master, so it is tracking. You just write git fetch, something like that. Look at this particular file here. The file is still with goodbye for today. The 8th line is not seen because we just said git what? Git fetch. As you can see here, after git fetch, we downloaded all these commits, but yet to be merged to what? To our current local branch. So in order for us to be able to see that, we must say git merge. Now if we say git merge, look, now the 8th line has appeared. And this is what we said, git fetch plus git merge is done in a single command when you do git pull. Thank you very much for listening. I think we have actually explored and exhausted whatever we wanted to touch with our hands. If there is any question, please, you can ask that particular question, and I'm here to listen and guide you throughout the process.
Sawa. Mwalimu,
A question please.
kuna mtu nimekutafutia mwalimu, ameingia, nimemshawishi, amejoin kwenye grupu, anasema sauti haisikii.
Then that might be a problem to their side, because
Okay.
you are able to hear me, and if he's not able to hear, that is a problem from his side. Maybe he can just look into his settings of his machine, or something might have happened. But good enough is that this video or this session has been recorded, and after this
Okay.
session, I will share the video to our Google Drive, so that you can be able to rewatch it. Otherwise,
Okay.
if there is no question, any question, please?
Okay, thank you. I see there is umeonyesha kuna ile sehemu ya repository kutengeneza token and so and so. Sasa ukiwa unatengeneza ile token, utakuwa baadaye unatumia kule kwenye kupush, utaitumia, utafanya, lakini hiyo token ina expire. Ina expire time ya kutumia. Sasa ina maana ukiexpire ndo itakuwa na hivyo tena, unarudi tena kwenye kule unafanya hiyo process, au kuna sehemu ya kuseti ambayo unaweza kutumia limited access au
Okay.
kuna security?
Okay, briefly, if you go to your GitHub account, let me show you something. I said when you actually want to create your personal access token, you have a room to set the expiry date. For example, if you come here, create a Git. Sorry, where did I come? Okay, personal access token here. If you come here, I said if you want to create a new token, for example, you see what happens here is that if you click create generate new token, this particular box here shows you where you can set your expiration date. Now you can set expiration date for 7 days, for example, as the way as I did, or 30 days, which is the default one. 6 days, this is approximately 2 months. 90 days, which is 3 months. You can make a custom expiry date, but you can set your personal access token to no expiration. If you don't want that personal access token to expire, just say no expiration. But that is not recommended. And the reason it's not recommended is because if you share your personal access token, if somebody gets access to your personal access token, that means they can start actually exploring your repository without your knowledge. When you set a particular date, it means if it will be exposed some days later, after the 7 days which I just set here, I am safe, because they can't use that particular access token to explore my repository. So you have all the room to make sure you customize your expiration date. What do you want? When do you want your PAT to expire? That's up to you. Thank you. Another question, please.
Okay. Another question.
Okay,
Hello?
I'm listening.
Okay, another question. I don't know kama tuko tumefika huko, lakini kwa mfano nikawa na device more than two, I mean, more than two, na ninataka kutumia kwa hiyo Git kwenye nani account moja na token ile ile. So nitakapokuwa natumia, muda mwingine naweza nikawa natumia multiple terminal, I mean CMD. So nikiwa natumia hivyo, kutoka kuna madhara yoyote kwenye ile account, au tu nitakuwa naweza itakuwa inaruhusiwa, ni itakuwa inawezekana? Maana sijawahi kufanya, lakini nilikuwa
Okay.
na kwa kompyuta mbili, ikawa inanigomea na inasema moja ina huku moja, kama ukiingia huku ina log out,
No,
ukilog in.
I don't think that is a real scenario. Actually, I do have two computers here. I can log into my GitHub account from any end, and what is required that when you are required to supply a personal access token, when you log into another computer, you will just be needed to supply that PAT, and it will allow you to get into that particular account. I mean your GitHub account. So I don't see it that when you are using two different computers, or to be precise, you say two different terminals. Maybe you saw me using this is PowerShell, but also I've been using all the time. I've been using PowerShell, but also I've been using Git Bash. You saw me using Git Bash, right? And I don't think if I use Git Bash, it will behave different from when I use PowerShell or something like. Or if I'm using two machines, for example, I'm on this first machine, and maybe this same project is being run from a different machine. There is no restriction so far, according to the best of my knowledge. Maybe if there are other restrictions that have been introduced, I don't know them. But currently, what I know is that as long as those credentials are right, you can always access your repository, your remote repository. Thank you. Any other
Okay.
question?
The last question, kuna mtu nilikuwa najaribu alikuwa anajaribu, anataka aone mafaili yangu, yani aone mafaili yangu, yani anasema nipe username yako nikaone mafaili yako, na nimweke kama collaborator, kitu kama hicho, collaborator. Sasa mi kwa wakati huo nilikuwa sifahamu idea ya GitHub. Sasa naona ukimfanya kama collaborator aone mafaili yako, si atakuwa ndo anaenda kuchukua mafaili yako ambayo umekuwa umeyasave wewe kwenye repository yako.
Now the whole point of Git collaboration is for teams to be able to work on the same project from multiple ends, right? Do you understand what I'm saying?
Yes.
That's the whole point of Git collaboration. Because what you have seen, what you saw me doing here, editing a file online, was just to make sure that you understand the concept of push and pull. But what I did by editing a file online was a replica, or was just to mimic that someone else in their computer have edited the file. So if you allow somebody to be a collaborator, that means they will be able to access your repository, and they will be able to track the branches. And so when they work from their end, from their machines, from their computer, they will be able to push into that particular repository. And when you push that particular repository, they will be able to get the history or the commits from your end. They will be able to pull them, to download them into their local repository. That's the whole point of collaboration. You are working, they are working, and another person is working, another person is working. You are collaborating. So you put your changes online, somebody else gets them into their computer, they put their history online, you get them into your computer. That's the whole point of collaboration. But that doesn't mean that they will be able also to access other repositories which are private to you. They will only be able to access that particular repository which you have shared with them, not otherwise. So if somebody gets into your repository which you have shared with them, made them collaborators so that you can work as a team, they only have access to that particular repository. But if I understood you correctly, someone said you give them your username and your password. That is wrong. Because if you give them your username and your password, it's the same thing as giving a person your ATM card and you give them also your password to your ATM card. When they go to the ATM machine, they will be able to draw all your money because you have given them everything that you own. But when you share a repository with other team members, they will be able to only collaborate on that particular repository. Any other repository which is private and have not been shared with them, that won't be accessible. The only file that will be able to they will be able to access are the repositories which are public. So anybody can know your GitHub username. For example, if you look at this particular URL, you see my username here. Mwendesura is my username, right? So you can just come or you can just write github.com/Mwendesura. You can just search Mwendesura in GitHub, and then my account will come with all my public repos. You will be able actually to fork them and make them yours and start blah blah blah. You can contribute to my repository if I've made them public. Everything is possible. But to access your private repositories, then they need to have special permissions.
Okay.
Thank you very much for the question. I think that was the last question, as you said. Thank you, guys, for being part of this session here. The video will be available as soon as we end this session. And I believe that next Saturday we'll all be together to take further these skills. Thank you very much, and God bless you. Have a beautiful
Thank you, sir.
day.
Thank you, sir.